We've all studied statistics at some point in our education, but we may have never gained a true appreciation of why applying some of that statistical knowledge is important in the context of business and data analytics. Imagine you're traveling and you've just reached the bank of a very steep river. And you don't know how to swim. There's no boats. There's no bridges. When you look around, you find that there's nobody there to help you, but there is a sign. And on that sign, it's broken down into 4 quadrants. Over here, it says that the mean of the river is 4 feet. So what does that really mean? This is calculated by the average depth of the river at each square foot in the entire river. So that's what average or mean is. It's the quantity that's arrived at by summing up the depth of each square foot and dividing that sum by the number of measurements, the number of square feet measured. So your height is 6 feet. Do we have enough information to cross this river yet? If you said yes, I really appreciate your guts, but I wouldn't dare cross this river because I don't know if there's any point where the depth is more than my height, or if there's points with depths that are 7, 8, 9, or 12 feet. And if we don't know where those points are, we really shouldn't cross. But so let's say we uncover more of this sign and we see that max depth is 12 feet, min depth is 1 foot. So this helps us understand there are maximum depth values, right? We know that parts of this river are totally crossable. And the minimum is the lowest of the values observed, right? So we've got our maximum, we've got our minimum, and then we uncover some more of this sign, and it says that the median depth is 4.5 feet. This is the median depth at 4.5 feet. Median is the middle of all the points measured if the depths are arranged in ascending order. So this means at the median, 50% of this river, right, is above 4.5, and the max depth is 4.5, or the max depth is 12 feet. But 50% of the values that are here are over that 4.5 feet. So we can't really cross yet. We still don't have enough information to make a decision. And so let's say somebody's has really taken the time, they spent all this time on this river, and quartile 3 is 4.75 feet. So now we understand that only 25% of the remaining spots are over this 4.75, right? So now we just have a lot more knowledge. It means 25% of the measured values are greater than the depth, and we still might not be comfortable, but we're really starting to gain some analysis about where we can cross this river. And if we said percentile 90 is 4.9 and percentile 95 is 5 feet, right? That would let us know that only 5% of the measured depths are more than 5 feet. So we could probably take that risk, right? If we talk about the percentile 90 is at 4.9 feet, and 95 is at 5 feet. That means most of the values, if we stack them in order from 1 to 12, are between 0 and 5, right? So we're really understanding so much about this river, and we're getting close to crossing it, right? It's likely that you'd be able to cross knowing this information, right? For the most part, you have a pretty high probability, right? 95% chance to cross this river, and your journey should be between 1 and 5 feet. An unfortunate outcome would be finding the spot that's 6, 7, 9, or 12. So I hope that this helps. We're going to dive into how to make this and use Python and R in another video. Hope you found this useful. We'll see you again.